Hello guys, today I'm mainly going to talk about the screen module and the design process behind it. So this is our 3.5 inches TFT display with a capacitive touch control. But let me first explain how did that GPS module ended up here instead of next to the light controller. So the original idea was to put the GPS module near the light controller. So as you can see, there are pads behind it. But then I realized the antenna part of the GPS module has to have as unobstructed line of sight as possible with the sky. So this wouldn't work because I was planning to position this light module under the seat. So I relocated the GPS module to under the screen module. But right under the screen module, I couldn't place it behind the backing plate because then I would have a obstructed line of sight as well, because this is a ground plane and the antenna wouldn't work really well if it was positioned like this. So this is a really bad design. So I had to put it somewhere away from the back plate. So when it comes like that and sits in front of you, so it would have some sort of a clear view with the line of sight with the sky. So after I positioned the GPS module here, the moment came to connect everything together. For the screen, I need at least 7 cables. For the touch control, I need 4 more cables. And for the added GPS, I need 2 more cables. So in total is 13 cables. So this is for the GPS module, and this should go directly to the controller. So controller is running everything, the GPS module, the screen module, and all of the functions within the system. So this 13 pin cable goes right here to 7+6 connector. So it divides to 2 because there's not enough room here. When I made the cables, let me show you the actual cable. 1, 2, 3, 4. When I double it up, it is now 8. When I fold it once more, it is now 12. And now one more, it is now 13 cables. So running all of these cables from the handlebar to under the seat just for the screen is not feasible, and it's not a good design. So I had to make some changes in order to reduce all of these cables, and I came up with an idea and it worked. And now I can get away with only 4 cables. So what I did was I redesigned that backplate. Instead of everything running from one MCU, now there's another MCU handling GPS and the screen module, and the 2 MCUs just talking over the UART. So let me show you how it looks like now. This is the new design compared to the old one. As you can see, all of those 13 cables are actually running inside here, and I don't have to run all of them to here. So most of the cables were coming from this FBC connector here and here. This is for the touch control, this is for the screen interface, and those 4 cables for the GPS connect right here. They connect to the MCU. So this MCU manages all of the screen functions and the GPS, and this MCU to this one, they only talk over those 2 cables, the yellow and the green one. The rest is just plus 12 volts and the ground. So with this setup, everything works really well, especially the GPS module reacts to speed changes quite nicely. You can check out the YouTube short that I posted about a week ago. So now we can talk about waterproofing. So the only point of entry between this case and the screen is this gap right here on the edge. So what I'm thinking to do, I'm gonna put a small bead of silicone all around here, and when I close this up, so I will seal practically the only point of entry for the water. Somehow, if that doesn't satisfy me, I have another plan. I just made this frame which could sit on top of the screen like that. What this will allow me to, actually I can put another bead of silicone right from the inside part here, which will not be visible from the outside. And when I put it down onto the screen like that, it's going to squeeze out all of that silicone all around the edge, and it will seal the only gap that is the entry to the main case. And I can bolt it down from the side here, and there's another one at the other side that will securely be fixed to the main case. But first I'm going to try it without the frame and see how it goes, and I'll take it from there. So the mounting to the handlebar will be accomplished with this plate, which is fixed behind this case, just like that. Let me show you on the actual case. This is the older design. So in order to demonstrate, so imagine this is the handlebar. So it's gonna go like this. Of course, it's going to be thicker, so this one can squeeze the handlebar between the plate and the retainer clip. So it goes like this. We have one here, and then we have another one. So with this way, down the line, if I want to change the handlebar size, and I'm only going to change these plates, and I'm good to go. The only hole that is coming out of the case is the connection point to the main board with the screen, which is for these 4 cables. Now with the screen out of the way, let me talk about the PCB design. As you know, this is the old PCB design, and this is the old backing plate. In the old backing plate, we had 13 pins which required to connect on the main board. Now with this gone, we only have 4 cables, so we don't need all of these 13 pins. And then I realized by placing all of these connectors onto the main board, I'm actually locked to this type of connector. And if I want to change the connector type, I can't do it because they're already fixed. I have to work with these connectors, and I didn't like that. So what I did was I removed all of these connectors and I just replaced them with pads. It allowed me to reduce the size of the PCB. As you can see, it is about 20% or maybe 25%. Now all I have to do is just solder the cables, put any kind of connector at the end of those cables, so it just gave me more flexibility. And also, to be honest, the original size, I couldn't fit this under the seat because I didn't have this much room, but this one fits really nice and there's plenty of room for it. But let me show you the populated PCB because I mostly finished all of the connectors. So as you can see, even with the case on, it is still smaller than the original PCB, and everything is soldered inside the case, and now I can work outside of the case without even touching the PCB. I made my own connectors and I labeled them myself, so everything has a specific connector and where it goes. So let me show you inside the case. So I've made this case design with the idea of sealing it from the outside with the, as you can see, there's a small channel all around as well as under the cables. So the idea is to put some small bead of silicone again, and when I close it off, it is actually going to seal from all around, and when there's a gap right here, I can put some more silicone around here so it will be sealed from everywhere. I'm going to put some hot glue right under the exit of the cables so they wouldn't pull on the PCB and the solder joints, because I don't want that. So everything has its place. For example, this is for the front signals. The front signals have a common ground, so when they go connect, I can actually use only one ground pad instead of multiple grounds. Show you here. So it connects to 1, 2, 3, 4th pad, so corresponds to 1, 2, 3, 4. So the front signals connect to DRL's negative. So let's check out the rear lights. So again, rear lights have a single ground pin which connects to 1, 2, 3, which is 1, 2, 3. So it goes to the brakes minus. Front and the rear light double up on the 1, 2, and 3. So let's check which one are those. So the right blinker left blinker, and the DRL. So as I said, you can put as many cables as you can onto the pad. This means that you can connect as many lights as you can, because one pad set actually supports about 6 amps of power, which is ridiculous. We have a main power input, which is going to be 12 volt in my case. This is for the front lights. This is for the screen, which goes directly like this, easy as that. Everything is connected with their corresponding connector. This is for the check. This is the headlight. This is for the handlebar switches. This is for the RGB lighting. This is for the battery sensing. And this is the horn. This is the brake sense, rear lights, and this is the front signal lights with the DRL built into them. So yeah, so the next video is probably going to be about demonstrating everything, connecting everything, show you how it works. So yeah, see you on the next one.